Welcome back, 6th graders. Today we're going to be looking at similar and congruent figures. By the end of this lesson, you want to be able to identify similar and congruent figures and also understand what that means. First, some definitions. So similar figures are figures with the same shape, but not necessarily the same size. So they look alike, but they're not the same size. Congruent figures are figures that are exactly the same shape and same size. So why don't you go ahead and pause the video and then try and figure out whether each pair of shapes is similar, congruent, or neither. Alright, on these first two, they are the same shape, but they're not necessarily the same size, so these would be similar. On our second group, the rectangle and the square, since one's a rectangle, one's a square, they are neither. And on the pentagons, even though the one is rotated, they're the same size and shape, so these would be congruent. Now when we talk about similar and congruent figures, we also have to talk about corresponding sides. Corresponding sides are the sides of congruent or similar figures that match with one another, or in other words, they're in the same location on the shape. So we want to name the corresponding sides. So if you look at our triangles, and order is super important when you are naming things like corresponding sides. So line segment AB corresponds to line segment DE, because they are, if you look, in the same location and in the same order. So A is on top, B kind of looks like that right angle, same thing here, E kind of looks like that right angle, so DE. Our other sides would be BC corresponds to, instead of writing it all out, EF, and line segment AC corresponds to line segment DF. So now you go ahead and pause the video and see if you can pick out the corresponding sides for our two rectangles. Since they're orientated the same way, we can kind of just look at it. So I'm just gonna put CT for, we have QR corresponds to WX. We have RS corresponds to XY. We have ST corresponds to YZ. And then we have TQ corresponds to ZW. So the real reason we want to use corresponding sides is that helps us actually prove that figures are similar to each other. And we can do that using proportional relationships. So up here we have triangle DEF, and it's a right triangle, and it has legs 6 and 8. Now in a right triangle we have two legs and what's called the hypotenuse. The hypotenuse is always the side opposite the right angle. Even though all three of these triangles on the bottom are right triangles, they're not necessarily all similar. What we're going to do is we're going to use proportions to prove that they are or they are not. So what I'm going to do is I'm going to start with DF. So DF is 6. We are going to compare DF and make sure it's the same proportion as FE. Okay, so an FE is 8. So we're going to look at our different proportions. So they're going to be on the top. So in our first triangle we have XYZ. XZ is in the same place as DF. So we have 6 over 5 has to be the same as 8 over 12 because YZ is in the same place as EF or FE. Now, since 6 over 5 is an improper fraction and 8 over 12 is not, these are not similar. Okay. On our next one, we're going to use the 6 and the 8 again on top. Okay, so in the first one, PR is in the same place as DF, so it's going to be 6 over 3. And then we're going to have 8 over 4. 6 over 3 is the same as 2 over 1. 8 over 4 is the same as 2 over 1. So these would be similar because proportionally they are the same. And then lastly we have 6 over 9, and we want to know if that's the same as 8 over 12. 6 over 9 reduces to 1/3. 8 over 12 reduces to, oops, sorry, not 1/3. Is divisible by 3, so that would be 2/3. So 6 over 9 is 2/3. 8 over 12 is 2/3. So this one is similar as well. I know this might seem a little confusing, but we'll get some more practice with it. Make sure you leave a question if you have one or you ask it, and we'll go from there.